increasing, decreasing, constant behavior of a function. This material is very easy to understand, so I gave you a graph. So what is increasing? Increasing, decreasing, and constant, they are talking about the slope of the function. So for the graph I gave you right over here, so increasing, do you see the green line? So this line is increasing, but you might be asking, hey, the arrow is going down, but you say this is increasing. How do you explain this? The easiest way to think about this is as x increases, y increases. So from left to right, do you see that the x value is, you have to look from left to right. Okay, look from left to right. From left to right, so as I move my pointer along the line, do we agree that x is increasing at the x value, and in the meantime y is increasing? So x goes up, y goes up, so therefore this is increasing. And then for constant, constant means a horizontal line. Horizontal line means the orange line, the slope is equals to 0. And then decreasing, decreasing means downhill. As x goes up, as x increases, y decreases. So as I move along, so x is increasing, right, from 3, 4, 5, 6, 7, 8, 9, 10, so on and so forth. But in the meantime, y is decreasing. So we have going up for increasing. You have to look from left to right. So before we start, keep in mind, look from left to right. Left to right. Increasing means going uphill, just like riding a roller coaster. Increasing is going uphill, constant means horizontal, and then decreasing means going downhill. All right, so let's take a look at these three examples. So I have an orange function. We have f of x equals to x to the third plus 3x squared minus 1. The graph is right over here. So as we can see, which part is going up? So the going up is from negative infinity, right? From negative infinity. Oh, I should point at my pointer first. From negative infinity and then go up like that. Do you see this? Do you see my cursor right over here? So just like playing a roller coaster. Okay, so going up, and then I will reach to the maximum point at x equals to -2, and then go straight down to reach x equals to 0, and then going back up. All right, so let me put the graph back. And then for increasing, let's go from left to right. So we start with increasing, right? So we go from negative infinity, and then we go all the way up to x equals to -2. And then start at -2 is decreasing from -2, and then all the way down to 0. Okay, by the way, what are these numbers stands for? This is an interval. All the we use x only. Okay, so use x only. And then increasing from x equals to 0 all the way to positive infinity. I believe that I should talk about the previous graph because I haven't discussed this piece yet. So for the green line, increasing, we go from negative infinity straight to x equals to -4. So from x equals to, not x equals to, from negative infinity all the way up to -4. And then we take a stop, and then the constant is from -4, x equals to -4 to x equals to 3. Do you see that? Constant x equals to -4 to x equals to 3, and then decreasing from x equals to 3 to x equals to infinity. It is pretty much straightforward. The graph explains everything. And then the next graph, f of x equals to x squared plus x plus 1 divided by x minus 1. I know you want to point out that x cannot be equals to -1, right? Because when x is equals to -1, the function is equals to nothing. I should say the function is undefined. So that's why there is a vertical asymptote when x is equals to -1. It's like right over there. My line is not straight enough, but it is okay. X equals to -1, there is a vertical asymptote. But that is not what we are trying to answer. We are trying to answer increasing, decreasing, right? So let's blow this graph up. So for increasing, we have negative infinity all the way to -2, and then going down. So we have going up. Should not point a graph like that. So we have going up, and then at -2, we take a stop, and then go down. And then we reach to the next piece, we have going down first, and then when we reach to 0, stop, and then going back up. Okay, let's draw this on the notes. So we have increasing first from left to right, from negative infinity going up all the way to negative 2, and then decreasing from negative 2 all the way down to negative 1, not negative infinity. So from negative 2, we go all the way to x equals to negative 1. So this is x equals to negative 1. Because the curve, do you see this piece? The curve is up as x, the curve is approaching to x equals to negative 1. And then we have another decreasing from negative 1 and then all the way to 0. And then we go back up, increasing, and then we have 0 all the way to past infinity. All right, last one. For decreasing, we have negative infinity, we go down all straight to 0, and then going back up, increasing from 0 to positive infinity. Okay, for this graph, I want to say a few more things, because before we end this video, you might ask me this, hey, we have decreasing from negative infinity to 0, and then increasing from 0 to positive infinity. It looks like the increasing and decreasing behavior switch or changes at x equals to 0. Then can you tell me what the slope is when x is equals to 0? You will study that in the first semester or quarter of calculus. At x equals to 0, the slope is equals to 0. What is this line called? Is this an extra line? No, it is not. This is called a tangent line. So we are when you take calculus 1, we will be using this tangent line, which is the horizontal line you see over there, to estimate the slope of this parabola at x equals to 0. The answer is, since the tangent line is horizontal, at x equals to 0, the slope of the parabola is equals to 0. Is tangent line always horizontal? The answer is no. So if you trying to estimate the slope of the parabola at x equals to negative 2, we will draw a tangent line as well. So the slope of the tangent line that is touching the curve at that point, the slope of the tangent line is equals to the slope of the parabola at that point. But since this is like out of the scope of this video already, you will learn that in calculus 1 anyway. I will just not talk too much about the tangent line. All right, so that is the end of this video. If you like the way I explain math, give me a thumbs up, a subscribe, and I will meet you all in the next lesson. Signing out.